Hey y'all, it's Mr. Reardon. I want to walk you guys through how to set up SPARKvue so that you guys can execute this Photosynthesis Lab tomorrow or today in class. Hopefully you'll watch this video on the evening of Thursday, October 19, as opposed to Friday morning, October 20. But either way, I want to make sure that you guys know how to use the Chromebooks that we have available in class to set up SPARKvue. And I'm going to walk you guys through that, and then I'll shoot another video where I kind of show you the setup. I'll do that on my phone. That video will follow this. They'll both be on our classroom. But bottom line, when you walk into the lab, you're going to find 5 lab setups. Each lab setup is going to have a Chromebook. It's going to have a Pasco carbon dioxide sensor attached to an Pasco air link, and then you'll also have a micro USB cable. Just to make things easy, and we're going to go ahead and plug our air link into the Chromebook using this USB cable, so we won't be accessing the wireless capabilities, and that'll save us a little bit of time. And then also, more importantly, my freaking iMac will not, or MacBook will not find anything via Bluetooth, so I can't show you the Bluetooth way, which is awesome. So I get to go to the Mac store and get that fixed at some point. Anyway, you'll also see what we call light cannons that Harrison and I devised and developed, and we're going to use those because what you're going to do tomorrow is you're going to measure the effect of decreasing light intensity on photosynthetic activity of spinach. And you're going to take 3 trials with a vessel that looks like this, 10 centimeters away from a light source, 30 centimeters away from a light source, and then 60 centimeters away from a light source. And you'll see that you've got 3 of these light cannons. You've got a 10 and a 20 and then a 30. So you can kind of see how you would set that up: 10 centimeters, 20, and then eventually 60. That stuff's pretty straightforward. That'll be in the next video. Let me get to it. When you open up your Chromebook or a Chromebook, have somebody in your group log in using your Jeffco ID, and then I need you to go to the Chrome store. Don't go to Play Store because you can't access it in this network, but go to the Chrome store, and then in the search bar type in SPARKvue. That's SPARKvue. Once again, SPARKvue. When you go there, you're going to see the typical Pasco logo in there, powder blue, and you want to say either Get App or Launch App. When you do that, it's going to download. It's going to take a couple of minutes, and then it will be on your alias on the Chromebook, and then I need you to launch SPARKvue. When you do that, if your sensor's not plugged in, you're going to see a screen that looks like this with the Pasco logo on the left. You'll see sensors, and it will say connect to a device to record data. That's what we want to do. So what I'm going to do right now is I'm going to take my air link, and I'm going to plug it in, and then I'm going to plug it into my computer. And you'll notice that this Pasco screen should change. It should recognize that carbon dioxide sensor. And sure enough, it did. So now we're looking at carbon dioxide, and this sensor has to be calibrated. So if you already had your sensor plugged in, as soon as you launched the Pasco app, this is what showed up. You guys don't want to hear this? It's great stuff, right?
She asked me to go upstairs with her, so.
Okay, there you go. So
There you go.
these sensors are supposed to calibrate to around 400 parts per million carbon dioxide in the atmosphere. Mine has to be jumping around from 691 to 10,000. Now, it may be close, but I want to make sure that you guys calibrate your sensor. To do that, you calibrate in the bottle. So you should have a 250 milliliter respiration chamber on your table. Place your CO2 sensor in that bottle. And then you've got a football-shaped button. I want you to press that button for 3 seconds. 1 1000, 2 1000, 3 1000. Let it go and just let it sit. I want you to put it down, let it rest on its side. I've got mine sitting on the side next to my computer. It's going to take about 60 seconds for that sensor to calibrate. You'll know it's calibrated when that green LED inside the football-shaped button goes from a solid green to a blinking green. When it blinks, it's calibrated, and it should show up somewhere in the ballpark of 400 parts per million. Now your goal tomorrow is to take 9 runs of data, and it's going to be likely that you'll need to recalibrate your sensor with every 3 trials, because this thing, even though it's a great piece of technology, can sometimes drift on you, so you need to take care of that. It's no problem. Just take a minute and calibrate your sensor. Now, what I want you guys to do is once you've got your sensor calibrated, you want to go ahead and build a page. And to do that, what you're going to do, I got to pull SPARKvue up here. I'm going to assume that I'm still recording. I want you to go to the build pathway, and you're going to get a screen change. It's going to ask you to select a template. I'd like you to select that second template, the largest box, and then also the column. Click on that icon, and now you've got some options here. Let's put a line graph on the big box. Let's put a digits display in that column. The next thing we need to do is select our measurement. So just scroll over the y-axis, click on that bar. You're going to get CO2 concentration opening up. Select that in parts per million. And then do the same thing over here on digits. Select measurement, select carbon dioxide, it pops up. Let's do another thing. I'm going to close that, I'll be there in a second. Slip over to your time on the x-axis, press time, and let's change from seconds to minutes. Now, last but not least, let's go ahead and change our time. Let's actually set the time that we run our experiments. We're only trying to go for 2 minutes here. So you've got this little clock icon down here. Press on that, and you'll get a new menu popping up. Click on automatic stop condition. Change from no condition. Select stop after duration. And now my device is kluging up. I got it. And let's change that from 0 to 2 minutes. Not 2 seconds, that'd be frustrating, but 2 minutes. Awesome. So now my sensor is going to collect data every second for 2 minutes. What does that look like? Well, once you're ready to go, you press play, and you're going to start recording data. Now remember that my sensor was calibrated, and you'll notice that it's reading around 340, 350 parts per million per second. Great. So currently recording just CO2 in the atmosphere of this bottle. When you have spinach leaves in this bottle, you would expect to see some change in the carbon dioxide level if photosynthesis is happening, and you should see that tomorrow. I'm just going to let this run for another few seconds. I'm going to get 30 seconds worth of data, and I'm going to stop my run. I stop my run by pressing the stop button. I do that because I want to show you a cool feature. If you click on this graph icon, the menu is going to explode for each or pop out. For every run, I want you to calculate the rate of CO2 uptake per minute. All you have to do is find this icon with a scatter plot and a line through it. That's your linear fit model. Check it out. You click that, it gives you the slope of that line. Here it's minus 61.4, and again, that number is nonsense. But what I would record in my notebook is absolute value, 61.4 parts per million carbon dioxide per minute. And that's one run. Recognize this. I'm having the device calculate rate. What we do with those rates is going to be kind of interesting. We'll get into that next week. Really, what you're going to see is we're going to have average rate of photosynthetic activity at 10 centimeters, the same thing at 30 centimeters, and also at 60 centimeters. And then I'm going to teach you guys how to do a regression analysis on those data, and that'll be next Tuesday. Once you've got that rate, you're golden. You can do one of two things. You can just turn that value off by selecting the curve fit tool again, or just leave it on there. Then you'll do a second run. Couple things you can do here is all you have to do to get a second run is press play. The second run will come up in a different color. There it is. Now, if you don't mind having multiple lines on the screen, leave run 1 up there. If that bothers you, all you have to do is click off of run 1, and there it is. Your Spark will show you up to 4 runs per screen. Let's say you're not clicking runs off, you're looking at all your runs. When you get to run 5, run 1 will disappear. But don't sweat it. You just have to scroll up and down on this legend to find it. So I'm going to leave both those up there. I'm going to stop that run. I'm going to explode my menu out one more time. I'm going to select my linear fit, and there I'm seeing the slope now is 4 or almost 5 parts per million carbon dioxide per minute. You'll do that 9 times. You'll record the average rate of photosynthesis by looking at the parts per million CO2 per minute, looking at the slope of each of these curves, and then we'll work with those curves next week. If you get into a problem, there should be some R&D kids in the room that can help you troubleshoot. I know Julia's in there. I've also talked to Elena, and I've also talked to Harrison, not Harrison, but Tyler. They worked through this with me yesterday, so they can be useful in the lab tomorrow. Thanks for listening to this. This should get you everything you need to get going up and going on SPARKvue. Make sure that you're getting that rate every time you do a run and recording that rate and writing it down in your notebook, because sometimes SPARKvue can crash and then you lose your data and everybody's feelings get hurt. Next video will show me showing the setup, and that should take a couple minutes. Appreciate your time. Y'all have a great day in lab. Make me happy. Shoot. Reardon signing out.